Hello and welcome to our mini project presentation. We are from Group 6. I am Aizat bin Azman and later in the video will be my partner, Ron Sherman. So, to start off this presentation, the introduction. So, rapid developments in modern life, particularly in population, economy, technology have resulted in a constant demand of energy. Since electricity is considered a privilege in modern culture, it is integrated with practically every modern aspect of life. So, having a steady supply of electricity is an indication of a country's adequateness in maintaining a happy living. So, basically, what it means that since we are living in an ever-growing country, a constant supply of electricity would be needed. So, so this mini project would be about that. So, for our methodology on our mini project. So for the customer interruption costs and system costs will be evaluated in terms of reliability costs and worth of composite generation and transmission, also known as HLII. So the optimal level of the system reliability can be obtained by the HLII by referring to the minimum total amount of customer interruption costs. So most of this will be explained by my partner Ron later in the result and discussion. Moving on.
Hello, my name is Ron Sherman from Group 6 and I will be explaining for the result and discussion for the mini project. So basically we were asked to use the MATLAB software to automatically calculate the composite customer damage function, state probability of generator outage at bus 1 and bus 2, transmission line statistic, state probability, departure rate, and frequency of transmission line state, the probability of failure, frequency of failure, and duration of the load curtailment, EANS, E-cost for the peak load of 90 megawatt, and to discuss on the result of EANS and E-cost. And all the data was shown based on the note in figure 3.2 and the data from table 3.1 and table 3.2, as can be seen here in the notes, table 3.2 and table 3.1. So basically we were asked to calculate everything here from the notes automatically by using programming in MATLAB software. So I will be explaining for the MATLAB software. So basically this has to be run. Let me clear. So this is the programming work for the mini project. As can be seen here, this is the state probability generator and this is the composite customer damage function CCDF. So first we will need to run everything, and here it can be seen the CCDF graph. And if you notice, this graph is the same as the graph that was in the note. And here we can see all the answer for the mini project. First of all, we have the answer for composite customer damage function CCDF, the state probability of generator outage at bus 1, bus 2, the transmission line statistic, the state probability, departure rate, and frequency of transmission line state, the probability of failure, frequency of failure, and duration of load curtailment, as can be seen here, and the ENS cost and E cost for the peak load of 90 megawatt, as well as the ENS total and E cost total. All these answers are varied and are the same from the notes here, as can be seen for the CCDF is 0.54, 2.04, 5.46, 19.22, 5.45, and as can be seen here, 0.54, 2.04, 5.45, 19.22 runoff, and 49.2808. Next we will ask to calculate the probability of generator outage at bus 1 and bus 2 and so on. And from this question, so on, everything will be based on this 3-bus system right here, and everything will be calculated based on this. So first off, we will given the table generation data and the answer for the generation outage of our bus 1 and bus 2, and as can be seen in our MATLAB, we compile everything, and after running it, we can see here the probability of generator outage at bus 1 and bus 2 is the same as the answer in notes. And next up, we have the transmission line statistic, where we first calculate the availability and unavailability for each transmission line, as can be seen here, line 1, line 2, and line 3, and we compile it together. After running it, we got the answer right here for line 1, line 2, and line 3. Next up, we calculated the state probability, departure rate, and frequency of transmission line. Here we calculated everything for 18 state, where the first state is no generation outage for every bus, and the second state is generator outage at bus line 1, and then the third state at line 2, the fourth state is at line 3, and so on and so on. And here we calculated everything. We key in all the input, all the data, and compile it together, and after running it, we get the answer here. Note that it is the answer here is times 10 to the power of 3, where this is 12, 1103, 1102, 885, 2193, 1976, and 1975. Next up, we will ask to calculate the probability of failure, frequency of failure, the duration of load curtailment. Here we input every data, all the calculation here, and finally compile it together in a table. And finally, we got the answer here for each state from state 1 to the 18th state. Here we can see the first state here is 0.8569, 18.8523, and 398.8.18. And if we compare to the table given right here, 0.85, 18.852, 398.18, which varies, as a comparison, and is correct. Finally, we will ask to calculate the EANS and E cost for the peak load of 90 megawatt. From the notes given, it was calculated up until 120 megawatts, but for the question, we will ask to calculate for only 90 megawatts. Here we key in all the input data based on the 3-bus system just now and the table given in the notes, and everything was calculated and compiled in the table. And after running it, we got the answer for everything. Note that all the answer here is to times 10 with the power of 3. Here it is 18.9, 39.82. I'm sorry, it's 398.2. And let's compare to the result in the notes, 18.85 and 398.18, which to show that our calculation in the MATLAB software are correct. Finally, we calculated the ENS total and E cost total for the discussion. And here we got 841.325 and E cost total for at 8.253 to the power of 3. I'm sorry, to the times 10 to the power of 3. And this result will be dragged to the report, as can be seen here. Before I discuss on the ECOS and ENS, as can be seen here, or the result, we compile every answer from the MATLAB software here. And as for the discussion for the ENS total and ECOS total, frequency duration, lot loss, location, and other social factors all influence the ECOS and ENS of the system. The result clarify how the ECOS and ENS are calculated in the power system. The ENS function is based on the probability rather than deterministic approach. However, deterministic methods can also be used to interpret how the system reacts in an emergency. In an emergency refers to the generator outage. Lastly, ENS provides precise information about transmission line during the planning or optimization of power network. Before I end my presentation, I would like to confirm that the MATLAB software, the answer in the MATLAB software is almost the same as the ones in the note, so wish to show that the programming in MATLAB software are able to calculate all the generator outage with this kind of problem. With this, I say thank you, and let's go back to Aizat for the conclusion. Thank you very much.
All right, thank you, Ron. So for conclusion, this mini project showed us that that we understood the basic concepts, theory of the generation and transmission reliability in power systems. So using the notes and explanations throughout the course, we are able to compute the probability of the supplied power and also use MATLAB to calculate the EENS and the ECOS, ECOST. So our findings suggest that when we're doing a reliability assessment, it is vital to include as many of reasons of uncertainty with power networks as possible in a single technique. This include not just those connected to the production, transmission, and load domain outlined above, but also those attributed to other sources, such as power distribution, emergency infrastructure, interactions, unexpected catastrophic events, and so on. So that'll be all from us. Thank you.